I'm here with Fabio from Cambridge Gallium Nitride devices. He's going to show me the latest from that company. So go ahead.
All right.
Yeah.
Hello. Okay. So our booth, we are showing two different things. We have a section that shows all we're doing in the data center space, and then the other piece to this side of the booth is covering automotive and industrial. So maybe I can show you first while we're here, maybe the automotive and industrial.
Yeah.
So briefly, the beauty of ICeGaN is that it can really be used in many different applications, including applications like inverters, traction inverters, because ICeGaN can be parallel. That's very different from any other GaN devices. You can only parallel probably a couple devices. We can parallel many more. So what we did here, we built an inverter, three-phase traction inverter, is 100 kilowatt using ICeGaN, and that's a demonstrator and has been used to run motors. And then we also built another inverter that demonstrates how you can push the frequency up we can. So this inverter is operating now at 40 kilohertz, but it can go all the way up to 80 kilohertz. And by doing so, you can shrink the size of your motor. You can design a motor designed to work at high switching frequencies, and you can really shrink the size, reduce the cost of the motor, increase the efficiency, and with GaN you can do that. So it's an inverter that drives high frequency motor.
Why do you call it ICeGaN? Is that your brand name?
Yeah, so it's our brand name because if you want to move on this side, I can show you on the pendant tab. So what ICeGaN is a GaN with also an IC all in one single chip. So it's a monolithic solution. It has both the HEM device and also has a Miller clamp, has an auxiliary gate, voltage limiter, logic inverter, sensing and protection, USD protection. So all monolithically integrated. So that's why we call it ICeGaN. It's an IC plus the switch.
At what stage are we with gallium nitride adoption? There's this whole debate, where to use GaN and where to use silicon carbide.
Yeah, very good question. So of course, GaN and silicon carbides, they overlap, especially if you are in the 650 volts. GaN still performs very well when you go to high frequency, above the 50 kilohertz, 100 kilohertz and so on, but there is some overlap. GaN, silicon carbide works very when we go to very high power, because you can go to 2.2, 3.3 kilowatts. GaN, what we have today is a 650 volt GaN, and our is a GaN on silicon, so it's a lateral GaN. As far as adoption, if you look at the latest report, in 2026, I think the total available market for GaN was around 600 million. So it's a pretty big one. I think the majority of that, or maybe more than 75%, was low voltage GaN. The rest was high voltage GaN. So GaN is definitely growing, and then of course, it's expected to go almost to 900 million in 2026. So the adoption of GaN is really happening. GaN is happening right now, and I think is no longer a question. I think it's also been proven to be very effectively from a cost standpoint. Is a very effective solution. So GaN can replace silicon, I think, in any voltage at this point.